Now, let me give you an example of how to deploy a XGBoost model on SageMaker. The first step is to sign the console, because we need to create a SageMaker notebook in the future and give it a policy. So we need to use the administrator or root account this time first. For example, I use administrator account created by my root account this time, sign in, and create S3 bucket as I have taught you before. Create a bucket, give it a unique name, UM, SageMaker, xgboost, create, good, and go to the SageMaker. From the left, we create a notebook instance. Here you can see I have created two notebooks before, and I have stopped. After use them, I need to stop them, and at any time I can start them again. Create notebook instance, give it a name. SageMaker, and here we choose notebook instance type. Since T2 is free, we just use T2, and you can choose other type, accelerating GPU, CPU, and here we give it a IAM role. To give it a this is kind of, in this step we need permission to create IAM role, and this is only allowed in administrator account, which is not allowed in the ML user account. Create a new role. Create a new role is like to give it a policy, to give it this notebook a permission of which S3 buckets it can enter. For example, the S3 buckets we create just now, SM, XGBoost, create role, success, you create an IAM role, VPC, and below we don't need to care about it. Create notebook instance. Pending. Here I will stop the video. Okay, now we have created the SageMaker notebook successfully, and now we can sign out the administrator account and use the machine learning account to build the model. Sign to the console with our machine learning user account instead of my administrator account we used just now. Sign in, and in this account we can see the notebook instance we create just now by the administrator account, because they are linked to the same root account. Let's open the notebook instance. Here, this is the Jupyter Notebook interface for SageMaker. And then let's upload our sample code and data. Desktop, project setup, SageMaker, this one, choose, upload, another data, zip file, choose, upload. And we rename it. Name. We use this to extract the zip file. Couldn't find a kernel matching Python 3, so we choose a Python 3. This is the old Python version the notebooks support. That kernel. Run. Success. Let's check. Okay, we have a XGBoost file extracted from this zip file. Close. Okay, now let's create the data we need to use in order to build the model. This time, indeed, the SageMaker still need the data to upload it to S3 in order to get the data. So the first step, we need to upload the data, the raw data into our Jupyter notebook. Upload, just set up data, test and train. Then we use this data preparation notebook to do some feature engineering on the local instance. This part I will just ignore it since it is very easy, just like the notebook in our local machine. Now we have prepared data successfully by call, backtest, backtrain. Then let's go to the most important part, build the XGBoost model using our SageMaker. Training template. Here we use Bottle3 to interact with AWS using our Jupyter notebook run and upload the first step, upload the data to S3. I set bucket name as this is my bucket name and this is the path in my bucket name. And let's print this location where we will store our data. And then this function helps us to write our dataset in this AWS instance to S3. The input is the file name, the bucket name, this one, and the path, which is the key in the S3. We use Bottle3 to interact with all the AWS service in the Jupyter notebook. Then, okay, we also let's also open a AWS console. S3 XGBoost. Here you can see we don't have any data. Then we write to okay, it has it. It is pretty quick here. Then retraining algorithms use Docker image. AWS maintains a separate image for every region and algorithms. For example, let's go to this website. This is all the algorithms supported by AWS. For example, K-means, PCA, LDA, and which we most interested in this time, XGBoost or neural topic model, and it also tells us which instances support like CPU, GPU, GPU, CPU, and it also, and scroll down, it also shows like which regions it supports and the training image, inference image, registry path. It's like they store a Docker in a specific region, and before you use the algorithms, you need to tell the SageMaker where the algorithms is. And for example, here, for XGBoost, it is deployed in USW West 2, East 1, East 2, West 1, and this is the this is the training image and inference image registry path. Let's have a look. And this is specify which version we want to use. This one get the rules, like which rule we are using. For example, we are using the ML user this time, and we have the permission to run both the S3 and the SageMaker run print rule. This is all the work we needed to be finished before training model. Get the permission, get the algorithms, and upload the file to S3. And then we build the model. A session is just like a TensorFlow. Create a session, and then we specify the estimator. It's still like find the algorithms in AWS. We tell it in the container. We tell them which region and the role, how many training instance we need, like how many T2 instance we need, and the training instance type, model location, and also the job name, the name of our training process. Let's define this estimator. And then compared to the AWS machine learning, this is the strength of the AWS SageMaker. It can tune the parameters. For example, here I set some parameters here, run unprinted parameters. Then let us tell us where the input data is. Training input, validation input, type is CSV, and S3 data is S3 training file location, which is the training location is here, like UEM bucket name, the training parts we upload in the very beginning. Run it, print, success. And then we train the model, estimator, which we defined here, fit, training data, validation data, run. Okay, now it is starting the training job and launching the instance. So I just pause the video. Okay, the model has trained successfully, and then we deploy the model. And the model, after running this code successfully, the model should be stored in S3 also. Let us check. This is the Amazon SageMaker dashboard, and from here you can see the model we trained is here, and the endpoints we created for the model. The endpoint is actually the model itself, and we can invoke the endpoint to make real-time prediction, just like it in Amazon machine learning. We can invoke the model to make real-time prediction. We can also check the S3 bucket, xgboost, backtrain, model, and model has been saved into here. Now let's make our prediction in the Jupyter Notebook. We can import the CSV, and these two packages are actually the parser, the data form parser for input data and output data. We can input this, we can import this and make prediction. After we have the endpoint, here, all the prediction or real-time prediction are just the same as the Amazon machine learning. Okay, that's all. The example for SageMaker and this example for Amazon machine